Okay, question 9, probability grade 11 and 12. Okay, 9.1, a certain company uses a camera detector system to detect trespassers. Okay, two independent cameras, A and B. That's very important because it is telling us that two cameras are that statement is telling us that two cameras are independent. And for independent events, probability of A and B is going to be equals to probability of A multiplied by probability of B. This is applicable only if two events are independent, which in this case they are telling us that two independent cameras A and B are installed. One at the front main gate and the other one at the back of the building. If someone trespasses, the probability that the person will be detected by camera A is 0.5. So we can say probability of A is equals to 0.5, and then the probability that the person will be detected by camera B is, okay, let me erase here, is 0.6, right? Yes. So the probability of A is 0.5. Let's write it down. Probability of A is 0.5, right? And then probability of B is equals to 0.6. Let's not even waste time. We know that the two cameras are independent, so we can therefore use this independent event formula to calculate probability of A and B, since the two events are independent. So probability of A 0.5 multiplied by probability of B, it's 0.6. So 0.5 multiplied by 0.6 is definitely equals to 0.3. So 0.3 is probability of A and B. All right, let's go straight into 9.1.1. If there is a trespasser, what is the probability that the trespasser will be detected by at least one camera? At least one camera. Now, in probability language, or rather in mathematics, when we are saying at least, in this case, at least one camera, we are saying one or more. Okay, one or more. So to calculate the probability of at least, we will write the probability formula, which says probability of A or B is equals to probability of A plus probability of B minus probability of A and B. Okay, interesting. So what are we looking for? We are looking for probability of A or B. I mean, think about it. Probability of A or B simply means probability that is happening on A or B. It's either this is taking place in A or B. It could be A or B. Okay, so we are looking for probability of A or B. Probability of A, they said 0.5, and then probability of B 0.6, and then probability of A and B 0.3. So let's substitute. Probability of A 0,5 plus probability of B 0,6 minus probability of A and B 0,3. And then what is probability of A or B? Probability of A or B is equals to 0,5 plus 0,6 minus 0,3, that is 0,8. Yes, that is your answer for 9.1.1, the probability that the trespasser will be detected by at least one camera. Right. And then 9.1.2, determine the probability that the trespasser will not be detected. Okay, we know the probability that the trespasser will be detected by at least one camera, one or more cameras. Okay, so in this case we want the probability that the trespasser will not be detected. This one, detected. So how are you going to find the probability that the trespasser will not be detected? Remember, probability ranges from 0 to 1. So it means probability cannot be less than 0. It cannot be greater than 1. So to calculate the probability that the trespasser will not be detected, we will simply say 1 minus 0,8. Why? Because from this 1, we already know the probability that the person will be detected, which is 8. The reason why we are subtracting, it's because we want to see from that 1 which we know 0,8, what is the value that is left. The value that is left is the probability that the trespasser will not be detected. So 1 minus 0,8 is definitely equals to 0,2, right? Yes, 0,2. So this is the probability that the person will not be detected. That's very simple. And then let's move to Venn diagrams. Okay, Venn diagram. At a certain high school, a survey was carried out on 110 learners. That is the sample space. 110 learners. Okay, the total number of learners. About their subject choices, the Venn diagram was the result of the survey in terms of mathematics, physical sciences, and accounting. These are only serious subjects. Okay, I'm kidding. But yes, the Venn diagram shows the result of survey in terms of mathematics, physical sciences, accounting. Okay, and we have Venn diagram. Here's our Venn diagram. Okay, let me try to. Okay, mathematics M, physical sciences P, accounting A. Right. So now they are saying show that X, remember our sample space is 110, so let me write it on top here. Show that X is equals to 8. What is X? What is X? X is the number of learners that are in the 3 subjects: math, physics, and accounting. As you can see there, X, a total number of learners that are doing mathematics, physical sciences, and accounting. They are doing all 3 subjects. So to calculate X, we need to add all this: 26, 9, 24, 12, 4, 15, 12, and equate the sum rather to not forgetting plus X, right, to 110. So let's do that. 26 plus 9 plus x, right? 26 plus 9 plus x plus 12 plus 12 plus 4, okay, 15 plus 15 plus 24 plus 12 again, 24, oh, 12 is already here, or there are two 12s, or there are two 12s, yes, it's this 12 and this one, so plus 12, and then this is equals to 110. So 26 plus 9 plus 12 plus 4 plus 50 plus let's verify, plus 15 plus 24, yes, 24 plus 12, yes, this is equals to 102 plus x is equals to 110. Then transpose 110 minus 102, this is equals to 110 minus 102, this is equals to 8. Therefore we have proved that x, which is the number of learners that are doing maths, physics and accounting, they are equals to 8. And then 9.2.2 rather, calculate the probability that a learner chosen at random does only one of the 3 subjects. So we want the probability that a learner is doing either maths, physics or accounting, does only one of the 3, only one of the 3, only. So which values are we going to take here? Only maths, only accounting, only physical sciences. Those are the values that we are going to take. Okay, so it's 26, 24, 15. So we need to add them and then divide them by the total sample space. Okay, so 26 plus 24 plus 15, 26 plus 24 plus 15, divide by 110. This is equals to 26 plus 24 plus 15 is equals to 65. Then 65 over 110, 65 over 110 is equals to 13 over 22. Then that's correct. That is the probability that a learner chosen at random does only one of the 3 subjects. Okay, and the very last question, calculate the probability that a learner chosen at random does mathematics and accounting, but not physical sciences. So we are looking at the intersection of maths and accounting. The intersection. Okay. Yes. So let's go to our Venn diagram. Maths, accounting, intersection. Here, 12. So you will say 12 over 110. That is the probability that a learner chosen at random does mathematics and accounting, but not physical sciences. That is 12 over 100, and you can simplify it, not 100 but 110, right? Oh yeah, 110, that is 6 over 55. That's correct.